11.2, electrolytes. You guys know what an electrolyte is? Most people, when I say electrolytes, they're like, Gatorade. I mean, yes, you're not wrong. Electrolytes are substances that, when dissolved in water, and so that's the key thing, right? The substance has to be dissolved in water, or the substance itself could be in the liquid phase. That's pretty uncommon in general chemistry. Okay, so this is the definition we're going to go with, is that it's an electrolyte if it's dissolved in water. Form solutions that conduct electricity. Okay, so let me get that up there and y'all can get that down. Why do they conduct electricity? And I have the answer there on the slide. It's because these substances produce ions in the water. Something can only be an electrolyte if it produces ions in the water. And ions are what allow the electrons to flow, which is what electricity is. You got to have charged particles for the electrons to jump and jump and jump and jump and jump. So you're looking for things with ions. We're going to classify electrolytes 2 categories, strong and weak. So strong electrolytes are compounds that completely dissociate. What do I mean when I say dissociate? Separate, break apart. Ionize is another word that we use. Strong electrolyte completely, and I mean like 100% of that compound splits into ions. Okay. What kinds of compounds are strong electrolytes? Here's really what you're looking for. You're looking for any soluble ionic compound. So this is why we're going to review solubility rules over the next several weeks. We're going to keep talking about, remember why this is soluble? You remember that this is soluble? I can get you, anybody, my handout from Gen Chem that has the shortcut solubility rules on it, if you want. Okay, for sure. Okay. Soluble ionic compounds. And the other compounds you're looking for are anything that is a strong acid or base. So in my Gen Chem class, we do go over what are the 6 strong acids and what are the 6 strong bases. Y'all remember any of them? So hydroiodic, hydrobromic, hydrochloric, sulfuric acid, nitric acid, perchloric acid. Okay, what about strong bases? Anybody remember any strong bases? How about sodium hydroxide? Bases are often compounds that contain the OH minus ion, right? Acids contain the H plus ion, bases contain the OH minus ion, right? Okay, let's see if I'm telling you the truth about some of this stuff. Okay. Why would I not? Oh, y'all, I'm a liar. Everything in chemistry is just a big fat lie in Gen Chem 1, right? Because every time I teach y'all something, then I come back and I'm like, but actually, really, There's an exception. Yeah. Okay, so this is just plain ass water, right? Sorry, y'all. Just plain water. Excuse me. I was saying ass a lot earlier today too, wasn't I? Big ass mom, big ass Adam, big ass Adam. Okay, you guys, just plain water does not conduct electricity. It is not an electrolyte. So why do they always tell you to get out of the pool? Don't stand in a puddle when it's lightning. Why? Because what you're standing in is not pure water, is it? There's other stuff in it, isn't there? Guess what that other stuff is? Electrolytes, because they're ions, you guys. Okay, all that stuff in the pool and in the pond and in the dirty water on there, it's all ions. It's also, here's a big, here's one, okay? Big one that shows up all over the place. Soluble ionic compound, salt. NaCl, salt. Will salt dissolve in water? Abso-freaking-lutely. How is it dissolving? Those water molecules are pulling those ions apart. So now I've got sodium ions and chloride ions running around this solution right now, right? Let's see. Yep. Any soluble ionic compound will do that. Acids, strong acid. Here's hydrochloric acid, HCl. When it's in water, guess what it does? What does it mean to be strong? That compound completely dissociates. Now, acids and bases do their own chemistry with water, which we're going to devote a whole chapter to. But strong, right? What about sodium hydroxide? Didn't I say that was a strong base? Sodium hydroxide. Yep. Okay. What is weak then? It doesn't dissociate 100%. If it's a weak electrolyte, it still has to create ions, correct? Electrolytes have to make ions, have to produce ions. Strong electrolytes are strong because 100% of it is now ions in the water. Weak electrolytes only dissociate partially. A weak electrolyte is a substance that only partially ionizes. You guys know this symbol? I was going to put this symbol here because I wanted to know who knew it, because sometimes I write it. Do you guys know that in a math proof, like a geometry proof, if you put those three little dots like that, that means the word therefore? Did y'all know that? None of y'all knew? Okay. So if you ever see me write those three little dots, that means therefore. Just so you know. Okay. What do I mean when I say it only partially splits? Guys, like I literally mean most of it stays together. That's what I mean. So if I'm talking about weak electrolytes, what we're looking for are typically what are classified as weak acids and bases. Okay. Here's an example. We're going to use this compound over and over again in our acid-base chapter, acetic acid. So we better just get used to the formula right now. This is the way I prefer to write this formula. This is how you guys will write it, okay? H, C2H3O2, acetic acid. Where do you find acetic acid? Vinegar. Vinegar is a solution. It's mostly water with a small percentage of acetic acid in it, but it's what makes vinegar be vinegar. Okay. Acetic acid is a weak acid. How do we know that? Like I taught you in Gen Chem 1, if it's not one of the 6 strong, it's weak. Weak meaning what? The word weak means it only partially splits. And so, in fact, we show that weakness with that double arrow. What did I say that double arrow meant earlier in the semester? The semester, like that didn't just start this Monday. Wow, okay. Good God, y'all. I'm so over all of you right now. Testify. What did I say that double arrow meant earlier this week? In equilibrium, it goes back and forth. That's still true. That is what's happening. Why does it keep going back and forth? Because this is weak. It doesn't 100% split and then it's done. It splits a little. Okay. Splits a little bit. And then these two guys, guess what they do? They come right back together. And then it'll split a little bit and then they'll come right back together. They can't make up their mind. Yep. Okay. Weak. Why is it weak? Partial dissociation. Is it really weak? Let's see if I can prove it. Uh-oh, where did I put it? Okay. Y'all see it? You see the filament is just barely glowing? Weak. So again, we're looking for weak acids and bases will always be weak electrolytes. Okay, weak acids and weak bases will always be weak electrolytes. Here's the classic weak acid. I'm just going to tell you now. Acetic acid is the classic weak acid that we use in Gen Chem as an example for all kinds of things. Here's the classic weak base. I'm not going to write an equation for it now. That's later. That's when we get to that chapter. Here's the classic weak base that we're going to see over and over again. What's that compound? Ammonia, NH3. Ammonia is a weak base. Let's see if it's true. That's true. Where did my ammonia go? I know we could probably get through this stuff faster if I didn't do so many demos. But I like doing demos. Don't y'all like watching stuff? Sure. Okay. It does. It slows me way down, but it's so much fun. Okay. It's glowing, but I would say it's not glowing as brightly as some of those strong electrolytes did. Do y'all agree? Cool. Okay.
So why does that one shine brighter than the other one?
The percentage that it ionizes is different. What makes it weak is that it's not what percentage? 100%. Okay. Also, any insoluble ionic compound would be a weak electrolyte. We're going to spend chapter 15 talking about how I taught you guys that the solubility rules, right? Solubility rules tell you that if it's insoluble, it does not dissolve. You remember how I said I was a liar? You remember that? You remember? Yeah. So the truth that we're going to learn is that when we say it's insoluble, it's actually just a little teeny bit soluble. Don't want to get into that yet. That's a whole chapter we're going to talk about. But so this was magnesium hydroxide, MgOH2. And solubility rules tells us that this compound does not dissolve in water. And you can see that it is not easily dissolving, right? It's very cloudy. There's actually a lot of solid there on the bottom. Okay. Let's see if it conducts any electricity. I don't even see any. Okay, so this is not even a weak electrolyte. It's a what? What's the word we're going to use? That is the phrasing we are going to use. Non-electrolytes. A non-electrolyte is a compound. It may dissolve in water, but it's not going to produce ions. So I guess over here, instead of saying any insoluble ionic compound, what I'm actually going to say here is there could be some insoluble compounds that would produce enough ions to conduct electricity, but there's no hard and fast rule to predict. Okay. So I wouldn't test you on that because you need to experience it for yourself. Non-electrolytes, no electricity, because why? No ions. No ions, no electricity. So what kind of compounds are going to be non-electrolytes that you can depend on? Anything covalent, right? Anything covalent. Covalent compounds do not conduct electricity. Sugar. Y'all think sugar is an electrolyte? It's not. People are always like, it's in the Gatorade. Yeah, it is. They put sugar in Gatorade to make it taste better. That's not an electrolyte. Sugar water. Nothing. What about ethanol? Remember we were talking about the alcohol earlier? Ethanol. Is ethanol soluble in water? Will it dissolve in water? Absolutely. But is it an electrolyte? No, it's covalent. That alcohol you're drinking at night is not giving you electrolytes, okay? I'm just letting you know. Now, if you add the lime juice to the tequila and you put some salt on the rim, then you are getting electrolytes. I'm just letting you know. I'm just letting you know. So, that's the end of electrolytes. Let me give you a little bit about this solubility. How are we doing? Oh, we good. We got this. What is solubility? Solubility refers to how much solute can dissolve. It is a value of the amount. Okay, so that's my abbreviation for the word amount. Yeah. That can dissolve. In a given amount of solvent. Okay. For example, look on your in-class examples. I know I skipped 2 and 3. That's we just had to. Look at number 4. At 40 degrees Celsius, the solubility of what's KBr? What's the name of that? Potassium bromide. The solubility is 80 grams per 100 grams water. What does that mean? What does that mean? At 40 degrees C, temperature is very important for solubility. Y'all can probably think about why. You can dissolve 80 grams of KBr per 100 grams of water that you have, right? That is what a solubility means. When you have dissolved the maximum amount that you can, you have what is known as a saturated solution. What does it mean to be a saturated solution? You have hit the max amount of solute. That's it. At that temperature. What does it mean to be unsaturated? You haven't hit that maximum amount yet, right? You can still dissolve more. Okay. Then there's a third term, but I'm going to wait a second to say it. So in this problem number 4, what if, as described in A, what if I have 60 grams of KBr added to 100 grams of water? What does that mean about the solution? Yeah. 60 grams in 100 grams of water is unsaturated. I can still dissolve more, right? What about that other one? What about B? 200 grams of KBr in 200 grams of water. Saturated. Why? What's the saturation limit? 80 per 100. If I have 200 water, the maximum amount would be 160, right? The maximum would be 160 for 200, and I may have 200 for 200. Yeah, so I'm saturated. 25 added to 50. Unsaturated. Again, take it back to the number you know, right? If I have 100, I have 80. If I have 50 grams of water, I can only dissolve half as much, right? I can dissolve 40. 25 grams of KBr is less than 40 grams. I am unsaturated. Yes. What about this thing called a supersaturated solution? Supersaturated means you dissolve more than can be dissolved because you've done what? Really, you're dissolving what can be dissolved at that temperature. Okay, you're increasing the temperature of the solution to dissolve more. Why does that work? So at a higher temperature, most solids, hang on, I'm gonna come back to gases. That's what I'm gonna finish with. Hang on. Here we go. Most solids increase solubility when you increase the temperature. You don't need to know specific numbers. You don't need to know this graph. But do you see that that's true according to this graph? Solubility increases as you increase the temperature. There's some exceptions, of course, but I'm not going to ask you about that. How are you going to remember that solids increase solubility when you increase the temperature? Think about making sweet tea. Guys who've had me before, do I like sweet tea? Oh, did we not talk about that in my class? We didn't talk about that this 8 weeks? Oh, you guys. I hate sweet tea. It's disgusting. I hate it so much. I hate it. I hate it so much. It's not my thing. So I hate sweet tea, but I know how to make it. And I know that you don't add the sugar to the cold tea. I know you add the sugar to the hot tea and then let it cool, right? Why? Because solubility of solids increases at increased temperatures. That's why. So how do you make that supersaturated solution? You heat up the solution, you dissolve a whole lot of solid in it, and then you let it cool. And as it cools, it's very like overloaded. It's super saturated. And any little agitation will cause the extra solid to come crashing out. That's how you get that rock candy. Did y'all see that slide I had up with the rock candy? We should make rock candy and ice cream? Guys, come on. My dentist is going to get even more money from me. Okay. What it means is that you're going to eventually, it's super saturated because when you bring it back down to a lower temperature, it has more than the max it can hold at that lower temperature. You artificially create a situation where you dissolve a whole lot, but then it comes back down to room temperature and it's super saturated. It's too much. Okay. And you can easily make the solid come out of the solution by agitating it. That happens easily.
Okay, so could that happen like if it's unsaturated?
Nope.
It can become saturated.
Wait a minute. Say it again. Say it again. What you're trying to say?
Like could unsaturated become
Super
saturated?
Only by you physically adding more. Physically, you would have to add more to it. Okay. Physically. So if it's saturated, if it contains the maximum amount and you keep adding more, what are you going to see in your jar or your beaker? You're going to see that solid still just sitting there. Yeah. That may be a question. I can't remember. In a saturated solution, would you see solid at the bottom or something? I don't know, that maybe that was a different class. But if it's saturated, would you expect to see solid at the bottom? If you keep adding more? Yeah, okay, that's okay. There we go. And then the last thing is gases. Okay? Can we do it? No, like for real no? For real no? Okay, well, we'll save gases for Monday then. I'm okay with that. I'm okay with that. What I am going to tell you though, what I am going to share with you though, okay. Thinking about solute per solvent, thinking about solute over solvent. This concentration you need to know to be working on your work this weekend. So let me tell you what this is, because this is a new word. Okay, you guys know if I write a capital M, that means what concentration? Okay, that's molarity. And that's what units? And moles, very intentionally, moles of solute, right? Per what? Liter of solution. It's one of the S words. There's 3 S words you got to keep track of. Okay, that's the one we learn in Gen Chem 1. That's molarity, moles per liter. But it's liters of solution, meaning the whole package, right? Okay, here's the new concentration that you need to know. Molality. You see the difference here? Molality. And this is a lowercase m, means molality. Molality is moles of solute per kilogram of solvent. Water's your solvent. Kilograms of water. How many kilograms of water? You can have how many grams of water, right? How many kilograms of water do you have? Moles per kilogram. Totally different, guys. Totally different. Don't mix them up. Totally different. Okay. So, you guys, over the weekend, got chapter 10 stuff to work on, right? What do you have? Let's see. Let's make a list. Let's make a list. Yeah, let's make a list. Chapter 10, set 2, due Saturday night. Okay, I just told you I want y'all to do a chapter 10 quiz. Due by Monday morning. Due by Monday morning. First chapter 11 set, started. You won't be able to fully finish it because I didn't talk about the gases, although you're more than welcome to look in the slides and see what I say about gas solubility, right? We're in lecture slides 3. You can look at it. This will probably end up being due Monday night, since we will only have one last thing to talk about for this set. And then I need you to start working on that lab solutions worksheet. This will not be due until at least Tuesday of next week, maybe even Wednesday, because we got to talk about how to solve some of these other problems. You should this weekend be able to do numbers 1 through 7. You have to do all of those this weekend? No. This is what you are able to do. If you're that person who wants to wait until whatever the night before to do all of it, okay, I wouldn't do that to myself. 1 through 7 is a review of different concentrations, including this new one, molality. Okay. Discusses solutions. What's molarity? What's all that stuff? 1 through 7 you should be able to do. But again, that won't be due until middle of next week, right before the test. Okay. You know I have to lecture before the test. You know I have to. I can't devote a whole day to it. Sorry. Okay. So we're done. If you need to go down to the lab room and you want to finish up answering the questions about the phase diagram, please do so, because I'd like you to turn that in today. And if you want to go down there and we can talk about anything else. But I'm sick of being in this room, so let's